Oh, that's a
apparently I signed into our district, not our
It's
school.
non-responsive.
I got one. I had to email them and I'm like, I thought it was everything, but apparently it's not. And she's like, do you go to Monroe Senior High School because you're in the district? I was like, I don't know why the district exists. Gosh.
Well, I was gonna say I got that email
Yeah.
and I haven't done it now. All right. So this next unit, this will be more math. We're going to actually calculate things, but not complicated calculations, but no longer reading a bunch of words. And,
Let's go.
yeah, we're not doing definitions and long examples anymore. So today should be pretty nice. We are talking about measures of central tendency, which is how to find the middle of a set of data. You've heard of these things before. So, first one, mean. I sure hope everyone has heard of a mean before.
Middle.
Yep, it's the middle. So we're trying to find different ways to measure the middle. What we do need to be careful of is there is a difference between a sample and a population. Okay, not in terms of how it's calculated, but in terms of the notation. Because if I'm doing an experiment and I said, okay, the average, I don't know, give me an example, what can't I think? The average amount in the lunch account of the students in my classroom. Is that necessarily the average for the whole school? No. And so to show, why don't you close that, Brady? You're gonna, I just don't want you to be tempted to be distracted. If we are talking about the mean of a sample, the variable is x bar, and we just call it x bar. It's an x with a line over the top. If we are talking about a whole population, it's called a mu. It's a Greek letter. It's like a U with a long tail in front.
Yeah, I was really sure to say.
It looks kind of like an
Yeah.
Not that thing again.
Now, to find both of these, it's the same. So if you look on your formula sheet, these are given to you. And the nice thing is, it even gives you the variable. So the first bullet under chapter 3, it says population mu. In this symbol, we will see it a lot, it's a summation. That capital E looking thing. So it's like this. And it just means add everything.
Is that an N on the bottom of population?
Mhm.
Capital?
Is this supposed to be capital or lowercase?
So on a sample, the notation they use, this means add up all of your x's, so add up all of our values, divide by n, the number in our sample. Okay, for a population, same thing. You add up all of your values, you divide by the number in your group. Then n's, it doesn't really matter. N is just a number. Sample, they do lowercase. Population, they do uppercase, just meaning it's everything in the whole group. Does that matter? No. You need to be able to find an average and just be aware, if I call it x bar, it came from a sample. If I call it mu, it came from a population. And if you forget, look at this formula sheet that you have forever, and it will tell you population mean, oh, that one's my mu. Sample mean, that one's my x bar.
Are you saying the view?
Mm-hmm.
Okay.
You
M-U.
Viewing. Okay.
Like what?
Wait,
View. Like viewing.
That's the one.
I can't.
It's
I
like-
can't even look up. No, just like look up Cooper Herner Snapchats.
Oh,
Okay, let's get back to this. So,
public
the following data represent the travel times in minutes to work for all 7 employees of a startup web development company. Compute the population mean. It's a population because it's all employees. What variable do I use for population? Okay, how do I find the mean?
middle of it.
Mm-hmm.
Is that the mu?
Yeah, that was
God,
just sloppy. Okay. So add up all these values. Grab a calculator if you don't have one.
Do we need a graphic?
Nope.
Somebody else.
Actually, you might want a graphing one just because I'm going to show you some hints later, if we get that far today.
Somebody else.
174.
And what would I divide by?
And whatever.
N. The
Seven.
number, which was 7.
Oh.
Right.
I got it.
Where's the-
Oh, you're on part B, we're on part
yeah,
A.
got it.
24.857.
Oh, okay.
Okay, please don't round all these to the nearest whole number. I know we kind of got lazy about that last unit, but now we need to be more precise again. So keep some decimals. 3 to 4 is usually sufficient. All right, what would my unit be on this?
Minutes?
Minutes. So it means on average it takes 24.8 minutes for someone to get to work. Okay.
So B would just be minutes. Okay.
Well, no, that's just the label on part A.
Oh.
Part B, take a random sample of 3 employees. So pick any 3. Who do you want to use?
23, 36, 23.
Okay. If I want to find this mean, what variable do we call it?
The middle.
bar.
That's the
X
X bar.
Okay. Add them up.
46 plus 36.
What would I divide by this
Add
time?
up the 23s makes 46.
If I say
Divide by 3 for the 3 employees.
27.3333.
Okay. So those 3 have an average commute time, 27.3.
If
So-
it's,
Oh, go ahead.
if it's like repeating 3s, do we have to put like 3 of them? Or can we just
You could put the bar over the top. All right. So will my sample mean always match my population mean? No. In fact, very rarely will it. But it can. All right. So we understand how to find an average, how to find the mean. Okay. Another option for finding the middle. So we have 3. We have mean. I guess is what the next one might be. Mode is one. Yep. Mean, median, mode. Median is just the middle if it's arranged in ascending order. So you can't just take the numbers as given, we have to put them in order. Median is the middle. Notation for that is just capital M. So if I ask you to find the median of this set, we have to put them in order from small to large. So we have 5, 18, 23.
26, 36.
All right, and then the middle is 23 because I have 3 on each end.
So that's the color median.
Mm-hmm. So you can write, a lot of times I just write median. You can call it capital M is what your textbook will sometimes call it. All right. What if I take my data, so we have 2 different options for finding the center, mean and median. Which one is better? If I say, here's my 7 employees, and I hire somebody new, and their commute time is 130 minutes. Let's find what our mean and median are now.
It's just the same, right?
So the mean, we now have to add up everybody and divide by how many?
Just do 173. 304.
Yeah, what, it add up to 174 to begin with.
Yeah.
38.
And we're dividing by 8 because there's now 8 employees. So it comes out to be 38. Exactly. So how did our mean change?
Went up.
It went up by quite a bit, didn't it? Our original mean for all 7 was 24.8 minutes. Now we're at 38 minutes, so it was a pretty big jump. Let's do our median. So we have our numbers in order, small to large, which you have on your last slide, if you don't want to rewrite it.
It's still the same.
But I add that 130. So if you're trying to find the middle, think of it as marking off small and large. There's no one number in the middle. There's 2. So what did we do? Do you remember? Okay. 49 divided by 2, so we get 24.5. Okay, the original median was 23. So it went up by 1.5 minutes, but what happened to the mean?
Went up by 14.
Yeah, so this was a large change. And this is a small change. This is kind of showing us when certain values are most helpful. In general, mean is the best option for finding the middle of a set of data. It's most accurate. But here's the problem with the mean. If you have an extreme value, a really high or a really low value, it has a huge impact on your mean. Okay, when I'm putting in test scores and I have somebody absent and I mark them as missing, it gives them a 0. What does that do to my test average? It tanks my test average. Does that mean the rest of the class did terribly? No. It means one person still has to take it. So the mean is great if all of your values are about the same, if you don't have any really high or low values. But if you have those extreme values, something that's so much different than your others, median is better. We call that resistant. So resistant is when extreme values do not have a big effect. Good luck.
Yeah, it takes you back.
Why does that take you back?
Because we had to carry our artifacts everywhere.
Terrible Tuesday.
Yeah, terrible Tuesday. We always had to carry our artifacts.
What's going on?
We had to carry like all our books that we had in a row.
What's she do?
She is an area officer. So median is resistant. The mean is not. So if I'm trying to decide which measure to use, I look at what are my numbers like? Do I have any extreme values or not? And that is a pretty good indicator of which one is going to be the most accurate for me. All right. So I put a diagram on here to kind of show you what's going to happen. If your data is skewed left, that means we had more low points. So those low points are going to drag that mean down. So if your data is skewed left, the mean is going to be lower than the median. Likewise, if your data is skewed right, that means you have more high values, so it's going to pull your mean up. So the mean is bigger than the median. If you have bell-shaped data, mean and median are about the same. So we can also tell from the shape of the graph which one would be larger or smaller. All right, let's look at a set of data. I want to show you how we can use a graphing calculator. Now, could we find the mean on this by ourselves? Absolutely. But we are going to use technology to do a lot of stuff in here because it just saves us time and it's beneficial. So everyone grab a graphing calculator. And if you don't have one, you could always just work it out by hand. We are going to go into, just like when we did the box plots, remember we entered data in the L1. So I'm going to go there. So I'm going to stat, edit, list 1. Do not delete the list, highlight it, hit clear, enter. And I want you to put all of these points in that first column. So even though this table is 2 columns, it all goes in the first one. Order doesn't matter, so if you miss one, you can put it at the end. You should have 16 values entered when it's all done. Does everyone have your data entered? Okay. I want you to go to Stat, and then we are going to use the right arrow to go over to Calculate, and we want number 1 variable statistics. Okay, this should come up. Just double check. It should say List L1. There should be nothing under the frequency. So if there's something there, just delete it. And then calculate. And hit enter. Okay. Our calculator is providing us with a lot of information here. I asked you to find the mean and the median. Did it give me my mean? Yep. It will always call it X bar on the graphing calculator. It doesn't know whether the data you put in was a sample or a population. This one was asking price for homes in Lincoln, Nebraska. Do you think these were all the homes for sale? No, that's a huge city. So this would be a sample mean. Okay. My median. If you look at your calculator and you go down, MED, that's median. So it will find it for us. So my median is 127,925. Just go down, hit your down arrow, because it's got more up. Go to Stat, Calculate. So, enter through that screen. Alright, does anyone else need help finding it on your calculator? Alright, so compare them. My mean is smaller than my median. How do you think that means our data is shaped? If my mean is smaller, I have more low values. Okay, and you could certainly confirm that by looking at a graph. If you wanted, I probably wouldn't require you to do that, but we have done it on the last one. Remember, we went into our stat plot and we did our box graph. And so we can see, is my data skewed left? Yes. It's not a huge difference, because is there a massive difference between these? No. The bigger the difference, the more skewed our graph is. All right, so that's mean and median. The other option is mode. Do you guys remember what your mode is? The most. The mode is the most frequent observation. You can have more than one. So if I have two different numbers that both show up 4 times, they could both be my mode. You may not have one. We may not have any repeated numbers. So, let's look at this problem. A set of data includes the values 11, 15, blank, 24, 29, 31. If the median is 20.5, can you find the missing value? Okay. How do we find the median? What does median mean? You're thinking mean.
The middle two.
Median is the middle. So I do have them in order already. So my median would be these two. Okay, so let's call this x for a second. We've all done algebra. Add them up, divide by 2, and what does that have to equal?
20.5.
Multiply over the 2. Subtract 24, and we get 17. Does this set have a mode? No. What about our drivers, our commute times example? Did we have a mode on those? Yeah, what was my mode? 23. That was the only one that was repeated. All right. Last problem of the day, I'm actually going to pull an example from the textbook. So if you would, open up to page 129. at problem 32. Mr. Zuro finds the mean height of all 14 students in his statistics class to be 68 inches. Okay, so we had 14 students. My mean was 68. Just as Mr. Zuro finishes his explanation of how to get the mean, Danielle walks in late. Danielle is 65 inches tall. What is the mean height of the 15 students in the class? Okay. Do I have the other 14 values? No. So I know to get my mean, I would have to add them all up, divide by 15, right? All I know is Danielle is 65. But I don't know these other 14 scores.
60.
Okay. Think about how we got this one. You add them all up, divided by 14, and got a mean of 68. So if we just take 68 times 14, so this is the height of the first 14 students. So to get my new average, oh, hit, you got it? So 952 plus 65 divided by 15, and we get 67.8 inches. So our new height is 67. We just couldn't resist.
I was holding it back.
All right, any questions there? So we are done with this first section. There's just mean, median, and mode.
Do we have homework?
You have some book problems to do.